Some characteristics of a function can be described by using the extrema and the end behavior. So in this video, we're going to go through how you can define and identify the extremas in a graph, and then also describe the end behavior. So first off, the extrema. Extrema is referring to the highest or the high points and the low points of a function. So in other words, the turning points of the graph. There are different definitions for the extrema. You can have a relative minima or a relative minimum, which just means it's a low point, but it's just not the lowest point. And then we got relative maxima or a relative maximum. The relative maxima is a high point on the graph, but it's just not the highest point. So that means somewhere in the graph it does go higher than that point, but that is a high point somewhere on the graph. It turns, so actually it's going to go downward at some point. Now the minima or the minimum is the lowest point, so it never goes below that point. And maxima is going to be the highest point. There's no point anywhere on the graph that's going to go higher than that. So just know relative, if you have the relative with the minima or maxima, it means you have a low point or a high point. It's just not the highest or the lowest. So we have a couple examples here. We are just going to describe what kind of extrema we have and identify the point at which we have the minimum or the maximum. So for this first one, I have a low point right here. That's the lowest. It never goes any lower than that. So we would call this a minima or minimum. So I'm just going to abbreviate it as minimum. And the lowest point that this one would be, and we'll just use the point be -1, and the lowest point would be 1, 2, 3, 4, -5. So you have a low point at -1, -5. There is no other extrema on there because the arrowheads are pointing upwards. That means it keeps increasing in both directions. The next graph, I have a low point here, I have a low point here, and I have a high point here. So let's do the low points. These two low points here, it doesn't go lower than that. So instead of a relative minima, we're going to call this a minima because that's the lowest point you could possibly have on this graph. And since I have two of them, I'll put both of them down. So one is going to be -1 and -1. And the other point is going to be 1, -1. And then I have a high point. It's just not the highest because the line does go above that turning point. So this would be a relative maximum. And the point for that one would be 0, 0, which is the origin. And our last one here, I have two turning points. I have a turning point here and a turning point here. Now both of these are going to be relative because the arrowhead here, it continues going high, and the arrowhead down here continues to go low to -infinity. So let's do this first one here. This is going to be a relative max. Means it's a high point, it's just not the highest point. And the coordinates of that one would be 0. The y would be 1, 2, 3, 4. So 0, 4. And we have this point right here, which would be a relative minimum. And the relative minimum, this would be x coordinate of 2 and a y value of 0. So that's how you can find the extrema, which means the highest or low point in the graph. The next part is going to be looking at the end behavior. So the end behavior is referring to the behavior of the graph as x approaches positive and negative infinity. So here you're going to be looking at the arrowheads. and there are going to be two statements that you are going to be writing down. I have the statements here. I just didn't fill in the last part because that's the part that we have to determine. It's always going to start as x approaches positive infinity, f of x approaches blank. And as x approaches negative infinity, f of x approaches blank. So we have three examples here. We're going to write the statements out here based on what the graph's showing. So one thing to help you out, or one way to help you out, is I'm going to put negative infinity here on my x-axis over here, and this is a positive infinity over here. And then up here is positive infinity, down here is negative infinity. So now, to write this out, I would start off with as x approaches negative infinity. That means when I go to this direction, where is the arrowhead pointing to? The arrowhead over here is up on top, and it's going up to positive infinity. So I would have f of x approaches positive infinity. And then the second statement, as x approaches positive infinity, so when it goes to the right, where's the arrowhead? The arrowhead is pointing up to positive infinity, so we would have f of x approaches positive infinity. Our next example. Here I'm still going to put negative infinity here, positive infinity here. This is positive infinity. Down here is negative infinity. So our statements. As x approaches, so when I go to the left, I have as x approaches negative infinity. So when I go to the left here, where's the arrow? The arrowhead is down here, so it's approaching negative infinity. And then the next statement, as x approaches positive infinity, so when I go to the right, to positive infinity, the arrowhead is up here, it's going to positive infinity. And our last one is a little bit different than what we had before with the other two examples. But here I'm still going to do negative infinity over here, positive infinity up here. Going up is positive infinity, going down is negative infinity. So now I have as x approaches negative infinity, so when I go to the left, where's the arrowhead pointing to? It's going straight to the left. It doesn't go up, it doesn't go down, it stays at 2. So we would say f of x is going to equal 2. It doesn't equal anything else. It doesn't increase, it doesn't decrease. And the second part, as x approaches positive infinity, so when x approaches the right side, where's the arrowhead? It is staying constant and it's going to the right. It still stays at 2. So I would say f of x continues to equal 2. So anytime you have a horizontal line, the f of x is always going to approach that same number, or it's going to equal that same number wherever that line is on, or wherever it crosses the y-axis. That's what it's going to equal. So that is how you can determine the extrema and end behavior of a function.